Good afternoon, everyone. I'm Euan. I am the Digital Preservation Manager at Yale University Library. We provide digital preservation services across the libraries, archives and museums on campus. I'm also co-PI on the Emulation as a Service infrastructure program of work, which I'm going to be talking about this afternoon. You can find me on Twitter there, and EaaSI has a brand new website. It's kind of fully there actually, this is my older, I've just realized this is my older set of slides, but it's at easi.info, not easi.cloud. And I'm going to be talking about software preservation and emulation and the EaaSI program of work. And I'm going to start by going through some questions, trying to answer the question of why we care about this at all. And then I'll talk a bit about emulation as a service, the technology that we've built EaaSI on that came out of the University of Freiburg. And then I'll talk about EaaSI and then how that works and what's coming next with that. So, firstly, why software preservation and emulation? Why should we care at all about any of this? Quickest answer is because everything is software. Many of you hopefully have seen this quite old paper now from the National Archives of Australia, where they outlined what they call the performance model, in which they established that all digital interactions are performances, where you have files and hardware and software files, and they all come together to provide a performance that the researcher interacts with. And that couples very well with this idea that, well, all digital files are software. And by which I mean, all digital files are instructions for a computer. If you look at a file in its basic form, it's ones and zeros that are interpreted by the computer. And a corollary to this is that all software is just a bunch of files. So when you open, say, a Word file, what you're really doing is opening a whole bunch of files, and it becomes, once you see just how many files are involved, you start to question, well, which file actually is the most important, and why are we only preserving this one file here that we, the .docx file, for example, and not all the other files? And just to illustrate that, I've got a quick video, which I'll try and skip through, if I can. Yeah, here we go. So this is showing a software that you can get on Windows. You can download it for free. It's provided by Microsoft called Windows System Recorder, and what it does is it records all the interactions that are going on in the file system when you do something on your computer. So what we're seeing here is the results of me opening 3 different files, a text file, a Word file, and a PDF file, all with the same content in them. And you probably can't see the details there, but each of these lines is a different file on the computer that's being interacted with when that single file is open. And this may well be the text file version. There are that many files that are actually touched when you just open a text file on your computer. So the question I would ask you is, which of those files is the most important one? And why are we only ever focusing on that .txt file and not all the other files that are actually doing the work to present the information to the end user? So all files are software is one reason why we should care about software preservation. Another reason is that we need to be able to have verifiable digital evidence. This is some quotes from a report I did when I was at Archives New Zealand, where we opened files in original software on original hardware, in new software on new hardware, and in emulated hardware in the original software. What we found was that pretty much every file that we opened had some weird attribute in it, though it will be a different attribute in almost every file. So the user that used the software to create the object that we were looking at had used a different feature from that file, from that software in each file, or the different users had. What that means is that it's highly likely that if you just use a single tool to open or migrate content from one file to another, or to open a file in the future, you're highly unlikely to cover every single feature that was in the original software. So there's actually a good chance that many of your files will not be, the content in many of your files will not be able to be presented properly to the user. It's kind of a complicated concept, but the distribution of the way software is used in reality means that it's very hard to ensure that any solution you have that isn't just using the original software is going to behave the exact same way in the future. So for example, these are screenshots which I've used many times in presentations, but they're quite illustrative. Screenshots from that research. This is a WordPerfect document. This is the original and what it looked like in the original software. This is the same one in more modern software. This was in the Windows Vista era. But you can see in the top left, there's these private tags that were added around the title by the software. They weren't there in the original. So what it's done is made you start thinking, well, maybe this this object should have been private, or should be considered private, or maybe it has some other meaning that we weren't aware of. And that's just the software. We did nothing to the file. It's the exact same file. Here's a similar example. This is a spreadsheet that comes from one of the corpuses that's on digipres.org. And it's opened in Quattro Pro for Windows 98, I think. And the same file opened in Excel 97 gives you this speech bubble that was not apparent when you opened it in the other software. So it's completely, this content that just wasn't there at all unless you use the original software. So the point being, the software files matter just as much to the performance as that data file does, because if you don't have the right software files, you're not going to be able to present the original information to the user. This is something we found while doing the Emulation as a Service programming work, that showing the original software and hearing it can really bring back memories and be quite emotive. And
You've got mail.
There we go, that's the last one. It really helps in selling digital preservation in general because it allows people to connect with this thing and make it seem old, which is a really hard thing to do with digital because digital is just ones and zeros on a screen and they seem modern by default. But when you get the original, what I like to call digital patina, and the sound and the look and feel of this old software really connects with people and it really helps you sell the value and the importance of digital preservation. This is probably the most controversial reason, but I would argue that it's the most economically viable option for long-term access to our content. I mean, who is actually doing migration? And if at scale that is, and if they are, how are they validating it? And then how long will they need to keep those migration tools around? Because if they have to keep the tools running because they might get one of these old files again in the future, then how are they going to keep them running? And if they're going to keep them running, why not just use emulation anyway? Because they'll probably have to use that to keep the tools running. Also, just testing files to confirm that they migrated properly. As we saw before, there's a high likelihood that obscure features were used by the users of the software that created the files you're accepting. So you probably need to test every single feature. If you're going to test these, this is what we found when we were doing testing, how long it took to test each one. And it's, I would say, cost prohibitive to test a reasonable number when you're doing migration at scale. And finally, emulation allows you to have a just-in-time solution rather than just in case. You do the emulation when you need to, when someone actually wants to access it. And one of those, I don't know if it's a dirty secret or not, but most things in our archives are never accessed, or very, very rarely accessed. So why are we putting in energy and using up carbon to migrate content into new file formats and maybe potentially keep the old ones as well, so doubling the amount of storage we're using, if most people aren't even going to access them, or at least they're very rarely going to be accessed? Why not put in the effort when we know it's needed, which you can do with emulation? And then another reason is for appraisal. So we are finding that it can be quite useful if, say, you've had a whole disk image transferred or even just a set of files from a particular period of time, for archivists to be able to open those files in a computer that was contemporary to them with some of the software that was used during that time on that computer to enable them to browse the files and just take a look as they were at the time. We can do the same with entire disk images of donated computers, so that an appraisal archivist can have a look in there and see if it's something they actually want, or see if they want to extract some things from it or keep the entire thing. And then there's all sorts of details there that are quite, that emulation helps to overcome, like this idea of linked files. If you don't have the files in the original kind of context with, if there's multiple files that are linked together in software, and you don't have them in that context and you aren't browsing them using the right software, you may find that they just don't work properly. And this is a screenshot from that same research at Archives New Zealand where we found this. We found some files that were linked, and if you didn't have them in the right place and you didn't have the right software there, you couldn't re-establish the links and you couldn't see the data as it was meant to be. And then I think this is the last reason, for preserving software computers themselves. To me, this is the least important, but also the most obvious one, which is software is an important artifact in itself. People are doing research into software more and more. This is a slide from a talk I did in 2010, which has two of New Zealand's prime ministers there. But it would be cool if we'd kept their desktops. I don't know if we did in New Zealand, but so future researchers could go back and have a look at what their computer was actually like when they were using it. And the guy at the bottom was one of the creators of Call of Duty Modern Warfare 4, which sold 6.5 million copies within 24 hours and grossed over $400 million. Why are we not keeping the computers that these people use to create these amazingly impactful cultural artifacts? Surely they're going to be an interesting object of research in the future. Some places are starting to present software as an object of study, like the Computer History Museum here has been acquiring software and making it available online. That's going to become more and more important in the future. All right, so that's a whole lot of different reasons why. So why emulation as a service, and what is it? So emulation itself is, hopefully you're all aware, but for clarity, it's when you use one computer to create in software another computer that you can then run the software that's compatible with that virtual computer on. So usually emulation doesn't require the emulated computer that's running on the second computer to have the same hardware as the computer that's hosting it. Whereas virtualization, in contrast, it does a similar thing. So it allows you to have multiple virtual computers running on the same underlying host computer, but those virtual computers have to be compatible at a hardware level with the host computer. What's great about emulation is that then we can run things that were created for computers that are no longer at all compatible with modern computers. Emulation as a service is software that was created at the University of Freiburg that allows online access to a whole lot of different emulators via a standardized and simplified interface. And it allows you to create pre-configure systems and then use those for accessing all sorts of different things, all just using a web browser. Here's a whole bunch of features. You can do a lot of really cool stuff with it. One of the coolest things, and especially when you're thinking about the environmental impact of all of this, is that with emulation as a service, you can create one virtual computer, make a change to it, like install some software on it, and then save just the difference. And then when you go to rerun that virtual computer in the future, it brings those two parts together and it makes it into one again, and you can reuse it that way. So in this example, there's 6 different computers. If we had to duplicate the entire hard disk for each of them, it would have used 30 gigabytes of data. By being able to create these, what we call derivatives, it uses 83% less data. So emulation as a service infrastructure is the program of work we're grant funded to push forwards, which is trying to make access to emulation as a service and access to software preservation technologies and emulation in general much easier. That's why we call it EaaSI. But some of the problems we're trying to solve are that finding legacy software is hard. So you may be able to get access to emulation as a service, but where do you find the old software and how do you run it? Do you have the documentation that you need to be able to understand the software and make use of it? Are you even able, do you know how to configure it? There are some applications. One that comes to mind from my experience is old AutoCAD for DOS. Very hard to install. I could tell you stories about that, but it's very hard to install. And it's all mostly, until you get to a certain point, keyboard configured. So what EaaSI is trying to do is address all of these problems, including integrating it with other types of workflows. And our goal is to provide technology and services for the application of software emulation across a diverse spectrum of professional disciplines, organizations, and individual use cases. Usable software forever. So we want this to be accessible forever. And we do this through a suite of technology, user services, and research activities. So our core services are search and discovery, so we make it very easy to find pre-configured computers that have software already installed on them, just using a web browser. So you can go into the EaaSI interface and search for, say, the one that always comes to mind is Office 97. It's one of the most common applications from the past. And you'll get different computers popping up that have that already pre-configured and installed on them. and you can just add your content and run them. You can import whatever you want and access it in there. You can create your own new computers using that derivative model. And you can manage access to all of these computers. So if you install this in your organization and you only want certain people to be able to access it, you can do that. All right, I'm going to skip forwards because I'm running through time. We're also taking this general idea of emulation in a browser and adding a bunch of different services on top of it. We're adding what we're calling a universal virtual interactor, which allows you to submit a file and have it opened automatically in the original software. So I uploaded one here, and what happens is a little script runs in the background. It says, go grab the file from the hard drive of the virtual computer and open it in the software that's associated with it. So it will allow us to connect all of our catalogs to this tool and finding aids and have users be able to just click on an object and have it open in the original software. This is the same example we saw before with the pop-up. If I let it run, it would show the other version opening. In fact, maybe I can... I better skip for time purposes. But in terms of benefits of EaaSI, it makes finding software much easier. We get all the emulators already pre-configured. You don't even need to think about it. And it makes creating environments really, really easy and makes configuration and documentation of software really easy. Here's the interface. This is a short video. The current interface, it's being improved all the time. We just received another $1 million of funding for 2 more years, in which we're adding even more features. I'll skip past this. There are obviously some challenges that make any of you wanting to install EaaSI and use it probably a little hesitant, but I can talk a little bit about these. So legal copyright is a big one. That's in regards to the software that we're using in there. Do you have the right to share and access the software that we've pre-configured? Do you have the right to make it available to your end users? In America, we have some legislation that supports those of us working in non-profit organizations. But I know that's not the case around the world. There are still emulators that don't exist for hardware that we want to be able to emulate, but that can be resolved over time with a little bit of extra money. Dealing with distributed digital objects is hard. These days, everyone does everything on their mobile devices. Most of the data that's involved there and most of the software is on servers somewhere that it's very hard to get access to. That's going to be a huge challenge in the future. Integrating with all the different preservation systems and access systems out there is going to be an ongoing challenge, but something that every tool like this is going to have to face. And then another thing that we've started working on, and there's a presentation about this tomorrow, is being able to automatically associate objects with the right software that you need to open them with, because having to manually make those connections is a huge challenge, and we wouldn't want to have to do that. If you need to look at this, the slides I'm sure will be available afterwards, but that's the link to the legislation or the description of how we can use the legislation to do what we're doing in America. How am I doing on time? All right. So that's a very brief run through on what we're doing, but there's a few new interesting things coming in the future. We're looking at mobile emulation next. At the moment, the best we can do is Android, but we can do Android. Apple is a little harder for a bunch of reasons, but that may be a possibility in the future. We're adding, in the process of adding the emulation of networks of computers, of environments, and I'll demo that really quickly, and then doing a whole bunch of automation. I'll try and demo some of that as well. So is this going to play? So what we're seeing here is 2 or 3 computers networked together running as an individual thing and saved as a thing. So when I hit go there before or start, it loaded them all together as one kind of object, preservable object. And we're seeing the SharePoint server software running on Windows Server 2003. And now we're switching to the other computer that's in there, which is the Windows XP client. And you can see here it's connected to that server and you can browse SharePoint. Yeah, you can browse and see what's in there. And these 2 computers are isolated from anywhere else, so there's no security concern about getting data out of them. But they can talk to each other. So if you have any sort of client server set up, we're going to be able to make these accessible and preserve those for future generations. That includes things like databases, which are a huge issue, entire EDRMSs. I gave a talk at the ARA conference a couple of weeks ago about the potential to use this approach to, instead of transferring records out of systems, just transfer the whole system. It's much simpler. You're probably not going to access most of what's in there anyway, so why put in all that effort to extract everything out and transfer it when you could just preserve the entire system? All right, there's other things that we can do with the services on top of EaaSI, such as migration via emulation. So I mentioned very briefly that we're starting to do some automation. So when you have control over the whole hardware stack that the software is running on, so I'm talking about the end user software, like say Office again, let's go with Excel, you can control what inputs and outputs are coming into and out of it. So you can do things like move the mouse and put keyboard inputs into it. And then you can start to script those. So we can do things like automate opening a file in the original software, saving it as a different format, and then getting that file out again, and then doing that at scale over and over and over again. This has come from, this is a screenshot from the first mention of this and the first prototype of this that was part of the Planets project. We're re-implementing that in EaaSI so that we can do this at scale, and potentially do things like set up every piece of software that's in EaaSI as a tool that's documented via the PAR API as a migration tool. And also this can always be done on demand. So you can migrate when you need to using the original software, and you could chain them together if necessary to get to an even more modern file format. This is another example of automation. Let's see if it'll play. What we're seeing here is a EDRMS, electronic document records management system, and you're seeing a search term being put into, well, you will see in a second a search term being put into this form. The search is for disposal of digital debris. In the EDRMS, there's a bunch of documents about that. This automation, what it allows you to do is put in a search term. It'll spin up the network that includes the server and the client. It'll go do that search in the client, download all the files, and then export them from the environment. So you could have all sorts of old computers, old systems set up with these automations pre-configured on them to be able to get data out of them for future research requests. You wouldn't even need to know how to use it. You just need to know this is the search term the user wants, and you'll get all the results back. So it didn't show the end files coming out, but they're available for download at the end of that process. And I think, well, I'll skip that one, but there's all sorts of interesting applications of this automation stuff as well, like being able to do distant reading of software, to be able to compare different versions of software over time, to be able to analyze software as an object of study at scale. A couple of the things that we're wanting to do with this are automatic metadata generation. So load up the computer, go to save a file, scan the, do an OCR of the save as file types, and then save that information as metadata for that software. So instead of having to manually identify all the software that a piece of, all the formats that a piece of software is compatible with, we can do that automatically by doing this automation on every application. We can do that for the open and the save parameters. And then we can also create examples of every single file format that a software application can create, which can then be used to create file format signatures to feed into our file format identification tools. So there's a lot of potential for using this automation to do really good things that will support the whole digital preservation community, not just those using emulation. So, in summary, there's a lot of reasons why we really must preserve software, because we all are anyway. All the files that we're preserving are software. We're building on a lot of prior work to get to where we are with EaaSI, but we are trying to make things easier. And yeah, while there are challenges ahead, there are a lot of really interesting, really promising applications of this. And thank you to the Mellon Foundation and Sloan Foundation. I think they've now given us $4.5 million over the last few years, which is incredible. They don't normally work together, but this has huge applications for the sciences, which Sloan Foundation loves, for reproducibility, so being able to rerun the old software to reproduce science. And the Mellon Foundation obviously sees all the impact on the cultural heritage sector to be able to run this old software, to be able to access all the cultural heritage content that we have out there. Thank you.
I think we'll try and take some questions now. We were originally going to do questions at the end, but there'll be a format change to one of the presentations.
Thanks, Euan. That was really great. I'm tempted to ask about what the software development methodology of this looks like, because you talk a lot about adding features. But instead, I think I might ask about related. If this is all funded by grants, what's the long-term maintenance of this project look like?
Yeah, it's a very good question. It's been a focus, like a line item in all of our proposals since the beginning has been long-term sustainability. And we've been talking with Yale about our current staff members, and it's looking promising that they'll be able to be converted to Yale money. The development team, which is all still based in Germany, we're going to need to bring in funds for. So our plan at the moment is to do something similar to places like Portico and charge a fee that'll scale up depending on the size of the organisation to participate in EaaSI, the network. That will cover the extra costs that Yale's not going to cover, but Yale is stepping up and really seems to be willing to fund a lot of this on an ongoing basis. I don't know if I should share the amount we're looking to try and recover for that, but it's definitely a cost recovery thing. We're not trying to make any money, it's just cover the costs that we're incurring to keep this running. And also it's open source, so worst case, the software will be there. If someone else wants to take it on, they could, but our plan is to keep this running forever.
I've just got an online question from an attendee. Are there any concerns, risks about security? For example, if another user opens an old corrupt virus file? That's an online question.
Fortunately, there are very few viruses that I'm aware of that can jump out of the emulators. So any virus that someone opens up would stay within the virtualized or emulated computer. So we could potentially have a collection of viruses that you could go in and try out, which would be quite neat.
Really interesting to see that. I'm just interested in the relationship with migration and normalization and digital preservation systems, and whether or not an obvious extension, perhaps you're already doing this, is integration with digital preservation systems that are carrying out those normalization tasks, and this being an added feature to see how it ran, and whether or not this could be a pathway with the automation that you spoke about to normalization.
Yeah, we have some functions available via the API at the moment, and any preservation system could integrate with that. We want to make more available, and we also, like I said, want to make those, the idea of the migration via emulation, we want to document that in a way that it could be made available via the PAR API, the Preservation Action Registries. So then the process of Excel 2003, opening a file and saving it in XLSX or whatever from an older format, could be documented as a single action, and then the API for EaaSI could be invoked to do that from within Archivematica or Preservica or Libnova or whatever. We're not quite there, but we're getting closer, much, much closer.
You mentioned at the start and at the end that all software are files, and the examples you showed with EaaSI were files that were matching the files to the software that renders them. Does EaaSI also work with executables?
Yeah, absolutely. So any object that you can upload can be open in there, and if it's software, obviously it definitely works with software because that's the focus for us. And we have we've run video games in there. With all sorts of stuff that's running in EaaSI.
Hi, Euan. Thank you very much for your presentation. What plans have you got to maintain and improve the emulation software that you're using for all this over time?
We've talked about this. We don't have any hard plans. So the idea is that as part of the ongoing support for EaaSI, it'll be funding things like adding new emulators as they come along. There's a talk in this session coming up about stabilizing emulators and making sure you have the right version available. So we're probably going to keep all the ones we have now and just add more and more over time. That's exactly the kind of thing, though, that would also make for great one-off grant-funded projects where you pay someone to create a new emulator, or you get grant money just to add another emulator, because it's a one-off thing that then has value for everyone that's using the tool set. So I'd see us trying to pursue that as well.
Yeah, thank you so much, Euan, for your presentation. You mentioned licensing copyrights being a problem that you found a solution for in the US. The rest of the world will need to do something. Would you think that the success of EaaSI is a good thing for us solving our problems with licensing, or is it a bad thing because vendors might now be aware of the fact that EaaSI is a success? Many of us will ask for emulating older versions of Windows. Might Microsoft start increasing their license fees for older products or not? What's your idea about that?
The way it works in the US is we're allowed to do what we do under the Copyright Act if there's a series of caveats about what kind of organization you can be. And those organizations are unlikely to be spending a lot of money on licenses anyway. They're non-profits, I think entirely non-profits, and it has to be for research and teaching and learning purposes. If there was any money to be made, then there might be some risk that Microsoft or whoever would see this and say, hey, we should stop them, we should get the law changed or whatever. But I don't think there's enough money that they're going to be worried about it. I think that's the general conclusion, fortunately.
Thank you very much for a very interesting presentation.